Let us continue let us continue our journey into the cold regions of the world, high in the mountain or on land, flat as a pancake in Canada maybe, and where glaciers are growing. Glaciers are growing means it is cold because snow falls and doesn't melt. More snow falls on top and forms glaciers, and all the frozen water is referred to as cryosphere. Cryosphere. Okay, so let's read some of the things we already said. So we have snow cover over here, we have glaciers over there, we have a lake and a river, and maybe there is some ice on the lake, and there is some ice on the river, and of course there is frozen ground which we called the permafrost. If you remember, we saw some nice pictures of houses bending, roads bending because of the permafrost thawing from global warming. And you have sea ice here. Now we are adding a few more things. Ice sheet. As I said before, when a glacier goes to a certain scale on land or the mountain slope, we call it a ice sheet. You know, it's like a sheet that is spread over some 10,000 square kilometers or 50,000 square kilometers and so on. Does it matter the size? Yes, there is a definition, but you just remember it as a large piece of glacier, and remember that glacier grows on ice. But we said glacier can flow down the slope like molasses or like honey, and it does that, and it flows on to the ocean. So it is anchored to the land over here because it can only grow on land, but it can continue to flow and extend on to the ocean. That's called an ice shelf, and you can see that that is different than the sea ice. Okay, because sea ice is frozen seawater, and it is brittle, and it has different shapes and different properties and so on, and this is growing on land, and it has flown onto the ocean, and it has different properties. But if you want to get a little ahead, you can also think that, well, if the glacier grows and extends on to the ocean, then the ocean is warmer than frozen ice or glacier, hence it must be causing some melting here. If the ocean warms, maybe it can bring more heat here. The ocean has tides, maybe that can move the ice shelf up and down and break it off the ground. So all these things actually happen as more and more of the ocean warming continues. More and more of the glacier ice shelf melt from below can happen. Okay, so these are just things to remember. Frozen ground, increasing permafrost temperatures by up to 2 degrees centigrade, and active layer thickness by up to 90 centimeters since early 1980s. Sorry. So the ground that has been frozen for a long time since the end of the last ice age, because you're in a high latitude and it's still cold in the Arctic Circle and so on. But now with global warming, you keep on warming the air temperature, and that keeps on taking heat away from the soil and the permafrost. And permafrost, also has a seasonal cycle. What does it mean? When summer comes, some of the permafrost does thaw, but when winter comes, it freezes again down to deeper depths and comes back in the spring and summer and goes back. This is a natural cycle, but once human beings became very active and started to burn coal and petrol and gas with the Industrial Revolution, and they increased the temperature, then the warming during the summer and spring and summer, and the thawing or the freezing in the fall and winter began to change. So now you are melting more and more, and the active layer of the permafrost is getting deeper, which means it shouldn't be melting so far down, but it is doing that because of global warming. And snow cover between 1967 and 22, satellite data show a decrease through the year, with the largest decrease of 53% from 1967 to 2012. In June, most stations report decreases in now especially decreases in snow, especially in spring. Okay, so what does it mean? The winter is ending a little early and spring is too warm, and instead of snow you may be getting rain or just dry, no snow, no rain. So this is part of the global warming. Lake and river ice that we're talking about, contracting winter ice duration with delays in autumn freeze up, proceeding more slowly than advances in spring breakup, with evidence of recent acceleration in both across the northern hemisphere. So as I said, the spring arrives earlier because of global warming. The end of the winter happens earlier, so snowfall is less and ends sooner, which means the lakes and the rivers are not freezing as much, and they are not trying to freeze as early. If they were starting to freeze in November, now they are delayed into December, and so on and so forth. So winter ice duration, how long the ice stays on lakes and rivers, is also decreasing because the autumn is not freezing up as fast and the spring is arriving early, and the spring melt is starting earlier. So you have ice free duration which is longer than before in a year, and the ice covered time duration is decreasing. Glaciers are major contributors to sea level rise. Ice mass loss from glaciers has increased since the 1960s, which means more and more glaciers are melting, and that water is flowing into the oceans and the sea level is rising. Loss rates from glaciers outside Greenland and Antarctica were 0.76 millimeters per year, sea level equivalent, during the 1993 to 2009 period, and it jumped to 0.83 millimeters per year, sea level equivalent, over the 2005 to 2009 period when this report was written. And now it's still continuing to accelerate. What does that mean? 0.76 millimeters per year may sound like a small thing, and that is the sea level equivalent, which means how much the sea level is rising. You convert this loss of glacier mass into the sea level rise. If you increase the global sea level by 0.76 millimeters per year, you can multiply the 0.76 by the area covered by the oceans, and you see how much water that is. That is a lot of water, which means it's a lot of glacier mass loss, and this is accelerating. So it jumped from 0.76 millimeters per year to 0.83 millimeters per year. So when you see small numbers like 0.1 degree centigrade warming, don't think it's really tiny. That is a lot in terms of the energy, because now you take 0.76 millimeter per year or 0.83 millimeter per year every year, multiplied by the area, and to produce that much water by melting glaciers, how much energy do you really need? You take the latent heat of melting of the glacier and you get how much energy is going into melting glacier. That's the energy that is coming from the additional energy we are keeping by increasing greenhouse gases and preventing the thermal energy from going to space. So never be, dismissive of small numbers. You follow it up to see how much energy that corresponds to, and you can compare it to the total amount of electricity we are producing in the entire world, and you will see that this energy will be larger than that. Okay, so find ways to find analogies to see just how much energy is involved. Sea ice, what is happening between 1979 and 2012? Sea ice like this, Arctic sea ice extent declined at a rate of 3.8% per decade, with larger losses in summer and autumn. Summer melting is higher, autumn is also melting more, means it's not freezing as fast and as early as it used to. Over the same period, the extent of thick multi-year ice in the Arctic declined at a higher rate of 13.5% per year per decade. Mean sea ice thickness decreased by 1.3 to 2.3 meters between 1980 and 2008. What does this mean? Sea ice grows, so it has an area that it covers. The area can shrink at some rate, and that rate can be accelerating. And the sea ice has thickness, so it can get thinner ice. So area is reduced and ice is not as thick anymore. So its thermal inertia is reduced as well, right? And what else is happening? It is also becoming, starts to freeze much later in the year and starts to melt much earlier. So multi-year ice, the ice that remains year after year after year, can get thicker and thicker. Just like on land you can put snow and make it thicker and thicker and grow into a glacier because of the pressure. In the ocean you want ice to remain year after year, which means it did not melt through the summer. It was thick enough and it was cold enough that the sea ice in the open was able to stay as ice because the temperatures were still not able to melt it away. But now with global warming, multi-year ice is decreasing. So you used to have a lot of 5-year ice, 4-year ice, 3-year ice. Now you have less and less of the 5-year ice, less and less of the 4-year ice, and so on and so forth. Ice shelves and ice tongues continuing to retreat and collapse of ice shelves along the Antarctic Peninsula. Progressive thinning of some of the ice shelves or ice tongues in Antarctica and Greenland. So these ice shelves that stretch out onto the ocean and provide a lot of food and oxygen and other things for a lot of the biology that lives in the ocean also are getting affected by this, and the glacier shelf is retreating. It is going back, doesn't extend as far, and it is also losing mass, and eventually that means that this is going to keep shifting and you will begin to slide more of the ice sheet from the slopes onto the ocean, because the grounding line is, this is called the grounding line here, where the glacier is grounded and it's like a cantilever beam. The ice shelf is hanging out and is moving up and down. As long as it's not moving too far up and down, it can stay intact, but it can break off when you get strong storms or waves and tides and so on. Okay, ice sheets, both Greenland and Antarctic ice sheets lost mass and contributed to sea level change over the last 20 years. Rate of total loss and discharge from a number of major outlet glaciers in Antarctica and Greenland increased over this period we are looking at, from 1979 or so to 2012 or so, right? So it's all bad news, of course, and you have to remember it takes a long time to build these glaciers. Sea ice may freeze over years and may recover, but glaciers take tens of thousands of years to build, and if you melt it away, it's not going to build back so quickly. So you have to think about what will happen as you grow older. Will the glaciers still be there? What will happen to the polar bears that are on the glaciers, and so on and so forth? So this is a lot of concepts, and this is already 14 minutes long. So let's stop this podcast here and come back and continue to look at some more of the details of the glaciers and what they are doing. If you ever get a chance to visit glaciers, or if you already visited, you know how beautiful they are, how majestic they are, how colorful they are in green, teal, cobalt colors, and how the meltwater forms these beautiful lakes that also look amazing colors and so on. So you want to keep this beauty for much longer than you have to worry about global warming. But not get scared of the future, but think about what you can do to change the future. You can find solutions to reduce emissions. So we'll talk about that later. We'll come back and discuss more glaciers in the next podcast. And see you.